Good morning to all of you. Now we are in the third day of secants and tangents. This is Mova Prasad signing into YouTube DCEB Suryapeta channel. So already Pratap Reddy sir discussed about the main basic concepts and what is the difference between a tangent and a secant, and what are the when we will get the parallel tangents, and how many tangents we can draw from a point on the circle and external outside the circle. So today sir will discuss about the remaining part of exercise number 9.1, and after that how many tangents we can draw from a point which is outside the circle and its constructions. So Pratap Reddy sir, please go through the concept.
Good morning, everyone. Children, we are going to solve remaining problems of exercise 9.1. Okay, just look at the problem number 3. Draw a circle and two lines parallel to a given line drawn outside the circle such that one is a tangent and the other a secant to the circle. Okay, first read the problem and understand the problem, then draw appropriate diagram. Okay. First, we have to draw a circle with center, name it as O. The problem saying that draw a line, first draw a line outside the circle, anywhere outside the circle, like this, like this, like this, anyone. Okay. Now I am drawing a line outside the circle like this and call this as L. I am drawing a line L outside the given circle with center O. Now the problem is we have to draw two lines. We have to draw two lines parallel to this line L. Parallel to this line L. One is tangent and the other is a secant. Now I am drawing a tangent which is parallel to L. Call it as M. Here just we can show by arrow marks, then these two are parallel. Representation of parallel lines. That means M is parallel to L and in particular M is a tangent to given circle. That is one point. Next, we have to draw another line which is parallel to given line, outside line L, and it will be a secant. It will be a secant. Anywhere, draw anywhere. N, call it as N. If we put a arrow mark, then these three lines are parallel. Representation of these arrow marks will represent, means those three are parallel. This is the solution of the problem number 3 in exercise 9.1, given in 9.1 exercise. Okay, first draw a circle, then draw a line outside the circle. We have to draw two lines which are parallel to the given line, outside line L. One is a tangent to the circle and another will be a secant to the circle. Why this is a tangent? Call it as P. Why M is a tangent to given circle? Since it touches the circle at only one point. At only one point. That's why M is a tangent to the circle and parallel to the line L. Why N is called a secant? Since this line intersecting the given circle at two distinct points, call them as A and B. That's why N is a secant and parallel to the given line L. This is the solution. Here L parallel to M parallel to N. Next, last problem of this exercise. Already I given fourth problem as homework. I think you have done the problem. Answer will be 12 centimeters. Okay. Next, fifth problem. Now we are going to solve last problem of the exercise. Prove that the tangents to a circle at the end points of a diameter are parallel. I am writing the problem also. Prove that the tangents to a circle at the end points of a diameter are parallel. Are parallel. Okay. Now we are going to prove this problem so that the tangents to a circle at the end points of a diameter are parallel. For this solution or proof, whatever it is. We can prove this statement in two methods. First, I will explain first method and then second method. You can adopt any one of the methods. Now, first draw a circle. With center O, with center O, draw a diameter is asking end points of a diameter. Diameter, just look at the diameter, draw the diameter. This is the center point. Okay, locate the points as A and B. A and B. AB is a diameter. AB is a diameter. Okay. Now I am writing AB is a diameter of the circle. Now, the tangents to a circle at the end points. What are the end points here? A and B are the end points of the diameter. Now we have to draw two tangents through A and B. Okay. Call them as PQ is a tangent through one end point A of the diameter. One end point A of the diameter. Next, RS, the line or tangent. Tangent is nothing but a straight line which touches the given circle at a particular point or at only one point. Okay. PQ is the tangent drawn through a point, end point of the diameter A, and RS is a tangent drawn through an end point of the diameter B. Now, we have to prove these two tangents are parallel. We have to prove. We have to prove the tangent PQ parallel to the tangent RS. These are the tangents drawn at end points of the diameter. That's why we have to prove these two tangents are parallel. Right. For this first method, this is common for both the methods. Now, first method, method 1. Method 1. Here, we are using concepts already learned in 8th and 9th, 7th, 8th, 9th concepts. If two, here, these are two lines. For example, if two lines are intersected by a line, another line, if this is L, M, this is N. Here, N is a line intersecting the given two lines, L and M. Here, N is called a transversal line. Transversal line. Then, alternate interior angles formed. These two are alternate interior angles pair. This is the pair of alternate interior angles. This is another pair of alternate interior angles. This is one pair of alternate interior. These four angles are interior angles. These four are interior angles. Since they are lying inside the given two lines. Inside given two lines. That's why these are interior angles. Alternate. Alternate means one angle is one side of the transversal line and the other angle will be another side of the transversal line. Then those are called alternate interior angles. These two are alternate interior angles. Already we know. These two are alternate interior angles. Okay. Now, if these two angles are equal, if these two alternate interior angles are equal, automatically these two angles also equal. Then the given lines are said to be parallel. And the given lines are said to be parallel. If alternate interior angles are equal, then given two lines are said to be parallel. Again, if these two alternate angles are not equal, then we can say L not parallel to M. L and M are non-parallel lines. That means intersecting lines. That's why we are using that property. Here, if we extend AB is a diameter. If we extend this as a line, we will get a straight line. Extend this. Okay. That means these two are given two lines here, and this line can be a transversal line of these two lines. Transversal lines, since this line intersecting these two lines. That's why this is a transversal line. Now, what are the interior angles? These two are interior angles. Already we know that tangent at any point of the circle will be perpendicular to radius through the point of contact. Already we know this is perpendicular angle. This is also perpendicular. Both sides. This is perpendicular 90 degrees. This is also 90 degrees. This is also 90 degrees. This will be 90 degrees. All are 90 degrees. All interior angles are 90 degrees. Here, that means the angle QAB the angle QAB equal to 90 degrees. Why it is 90 degrees? Since this tangent perpendicular to radius through point of contact. Already we know from that property. Okay, again, this will be equal to angle RBA. Angle RBA. Okay. This radius is part of the diameter. That's why I am writing QAB, angle QAB equal to 90 degrees. And angle RBA equal to 90 degrees. Both are equivalent. That means alternate interior angles are equal. Alternate interior angles are equal. Then this pair must be equal. The remaining pair also equal. Therefore, then we have to say, we can say, therefore, the line PQ parallel to RS. The line parallel to RS. That's all. The proof is over. Again, first we have to draw a circle with center O, draw a diameter passing through O. Next, locate the endpoints of the diameter as A and B. Then draw two tangents PQ and RS through endpoints of the diameter. We are using alternate interior angles property. This is a transversal line of these two lines, and these two are transversal lines and equal to 90 degrees. Equal. The two interior, whenever the interior angles are equal, then we can say the given two lines are parallel. That's all. This is the first method. Next. Second method. Method 2. What is the another method? Can be used? Here we are using a property. Just listen carefully. If two lines are perpendicular to the same line, then the two lines must be parallel. For example, these are the two lines. Given two lines. If these two lines perpendicular to the same line, this is L, for example, M, N, call them as L, M, N. L, M are given two lines. If given two lines are perpendicular, for example, here 90 degrees, this is also 90. If these two angles are 90 degrees, that means these two given lines are perpendicular to the same line, N. Then the given two lines must be parallel. Here L is parallel to M. We can say L is parallel to M. For the second method, we are using this property to prove. Okay. Just note down. Okay. Due to space purpose, I am rubbing this. Now, already here PQ and RS are two lines. Here PQ, the tangent perpendicular to radius, already we know perpendicular to radius through the point of contact. Here that we have to write. PQ line perpendicular to AO, radius AO. PQ tangent perpendicular to radius through the point of contact AO. Again, this can be written as the line PQ perpendicular to diameter AB. How? Since the radius is part of the diameter. Since the radius AO is part of the diameter AB, that's why we are extending AO as AB. Right. Here the line actually, the tangent PQ perpendicular to the radius AO. we are extending that. The line PQ or tangent perpendicular to the diameter AB. In the same way, RS, the tangent RS or line perpendicular to radius through the point of contact. What is the radius through the point of contact? BO. BO. Again, we are extending as RS, the line RS perpendicular to BO. BO is the radius. Here, this is R, this is also R. R plus R2 are diameter. AB is a diameter D. Okay, now BO is the part of the diameter AB. Is a part of the diameter AB. Therefore, RS perpendicular to the diameter AB. RS perpendicular to the diameter AB. Just look at these two properties already proved. Here, PQ is a line or tangent parallel to diameter AB. Diameter AB. If we extend this, this will be AB is called as a straight line. AB is called as a straight line. That means PQ, the line is perpendicular to the line AB. The line through AB. And RS is also perpendicular to the same line AB. Just observe. Same line AB. And these two lines perpendicular to the same line AB through AB. The two lines are two tangents perpendicular to the same line through A and B. Therefore, we can say, therefore, PQ, the line PQ, these two will be parallel. RS. RS. That's all. Since these two tangents are perpendicular to the same line, therefore these two must be parallel. This is the second proof. Okay, 9.1 is over. Now, we are going to discuss another concept or topic of tangents and secants, that is number of tangents to a circle. Number of tangents to a circle from any point, just note down, underline the from any point. Okay. Number of tangents, how many number of tangents can be drawn or exist from any point of the circle? That we have to discuss here. Okay. Now, first draw a circle. Draw a circle with center O. Draw a circle with center O with convenient radius. Now, how many types of points will be there with respect to given circle? What are the classification? What are the classification of points? What are the classification of the points with respect to the given circle? Just observe this circle. The circle will exist in a plane. Now, this plane, the circle divides the plane into three parts. Now, this is interior of the circle. Okay, this is the interior part of the circle. This is the boundary part of the circle. Boundary part of the circle, circumference. Then outside portion, exterior part. What all these parts is the exterior part of the circle. In the same way, points exist. For example, this is one point. These all are interior points. Okay, all these are interior points of the circle. we can say A or B, C, whatever the points we call them as A, B, C, D, etc. All these points are interior points. Now, what are the boundary points? Just locate a point on the boundary. Locate a point on the boundary. Locate a point on the boundary. These all are boundary points. Boundary points. For example, P, Q, R, S. All these are boundary points. Or PQRS lies on the circle. We can say lies on the boundary or lies on the circumference or lies on the circle. Next. What are the other type of points? Just here. All in exterior part of the circle. These are, for example, M, N, like that, X, Y, like that. All these are exterior points of the with respect to the circle. Okay, that means this is the classification of points. There are three types of points. One is interior points of the circle. Another is boundary points of the circle. Next, last one is exterior points of the circle. Now we have to discuss how many number of tangents can exist from all these points, all these type of points. Now, okay. From interior points, how many tangents can exist? For example, if we take the point A, interior point, how many tangents can exist through the interior point A? Just draw a line through A. Any side, anywhere. But it must be passing through A. Okay, now if you draw like this, this is a line passing through the interior point A. But this is intersecting the circle at two distinct points. This line is intersecting the given circle at two distinct points. If you draw through D, interior point D, this also intersecting the given circle at two distinct points. That's why these two are secants. These two are secants. If it intersects at two distinct points, then it is called secant. Already we know. But it cannot be a tangent. This cannot be a tangent. From this, what can you observe? Yes, you are right. No tangents can be drawn through interior points. No tangents can be drawn through interior points. Okay, that's all. That means 0. Number of tangents through interior points equal to 0. No tangents can be drawn through any interior point of the circle. This is the first thing. Next. Now, if we draw a tangent through boundary point or at a point on the circle, you take P, take the point P, draw a tangent like this. Like a tangent, draw a tangent like this. This is the point P. Okay, right. Yes, through S, draw another tangent like this. How many tangents can be drawn through a point on the circle? Already we know about that also. Only one tangent can be drawn through at a point on the circle. At a point on the circle or at a point on the boundary. Okay. Here also, only one tangent can be drawn through S. Only one tangent can be drawn through P. Similarly, R and S. Only one tangent exists. That's why there is only one tangent can be drawn through at a point on the circle or boundary point, through boundary points. That is the second one. Next, last one. Now, we have to draw tangents from outside point. That means exterior point. M is an exterior point. N is an exterior point. X, Y, all these are exterior points of the circle or outside points of the circle. Now, just guess it. How many points can be drawn through outside point, from outside point to the circle? How many tangents can be drawn from outside point to the given circle. Okay, your guess is correct. Like this. From the point M, we can draw like this. We can draw like this. Then MP or M like this. This is a tangent. This is touching the circle at this point. Same. Also touching this circle here. From outside point M, we can draw pair of tangents. That means two tangents. We can draw two tangents from outside point to the given circle. Two lines are possible. Two tangents are possible from an outside point. That is the third point. Okay, this is very important to the syllabus. We can draw. Again, I am saying we can draw pair of tangents or two tangents from any external point to the given circle. That's all. First, from interior points, number of tangents 0. At a point on the circle, number of tangents equal to only one. Only one. From an external point, number of tangents can be drawn. Number of tangents equal to 2. Number of tangents equal to 2. Okay. Now, we are going to prove theorem 9.2. Theorem 9.2. What theorem says? The lengths of tangents drawn from an external point to a circle are equal. I am writing the statement. Just I am reading the statement. The lengths of tangents drawn from an external point to a circle are equal. Okay. Proof. Note down the proof. For this purpose, first draw a circle. With center O. With center O. With center O. Then draw tangents from external point. Locate any point outside the circle. Then draw two tangents. Draw two tangents. Locate outside point as P and a point of contacts. Locate them as A and B. Join AO and OB and OB. Join AO and OB. Join OP also. Join OP also. Right. Now, what is the angle here? This is a tangent. PA is a tangent. PB is also tangent. A and B are point of contacts. Next, OA is the radius. OB is the radius. OA equal to, okay, it will be radius. It is defined as radius. Okay, now this angle will be perpendicular. This is also perpendicular. Already we know tangent is perpendicular to radius through the point of contacts. Through the point of contacts. Okay, that's all. From that, both are right angles. Then here two right angle triangles are formed. Just observe. Two right angle triangles are formed. Now AOBP is a quadrilateral. AOBP is a quadrilateral. But the line OP divides the quadrilateral into two right triangles. Now we are going to prove these two right angle triangles are congruent. These two right angle triangles are congruent. When we say two right angle triangles are congruent, by which congruence rule? Right, you are right. By RHS congruence rule. We are using RHS, right angle, hypotenuse, and side. That is the RHS property or congruence rule. Okay. By using that rule, we are going to prove triangle OAP and triangle OBP are congruent. Consider two right triangles. One is triangle OAP and triangle OBP. Consider two right angled triangles. Right-angled triangles OAP and OBP. Okay. Next, by RHS property. What says RHS property? What is saying? In any two right triangles, if one pair of corresponding sides, this or this, and one pair of corresponding hypotenuse are equal, then the two right triangles are said to be congruent. That is the RHS congruence rule. Okay. Now here OA equal to OB. Since these two are equal to radius. OA, OB, both representing radius of the given circle. That's why OA equal to OB. That means in these two right angle triangles, one pair of corresponding sides are equal. Okay, first point is over. Next, we are going to second point, last point, that is hypotenuse. What is the hypotenuse of the right triangle OAP? That is OP. These two are other two sides containing right angle. Then OP will be the hypotenuse. This base and height. These two represents base and height. This will be the hypotenuse. In the same way, in the right angle triangle OBP, these two are, one is base and one is height, or sides containing the right angle. Then OP will be the hypotenuse of this triangle also. That means OP is the common hypotenuse of both the right triangles. OP is the common hypotenuse of both the right triangles. Okay. That means OP equal to OP, common hypotenuse. Okay, right. Since it is common hypotenuse, both are same itself. OP equal to OP. Right, that's all. RHS property is over. One pair of sides are equal, and this pair are equal, and this is equal to itself. OP equal to itself. OP equal to OP. Corresponding hypotenuse are equal. Therefore, we can say by RHS property, triangle OAP is congruent to triangle OBP by RHS congruence rule. By RHS congruence rule, we can say these two right triangles are congruent. Then, now we have to prove. What we have to prove? The lengths of tangents drawn from an external point. The lengths of tangents. What are the lengths of tangents? One is PA and another is PB. One is PA and PB. We have to prove PA equal to PB. PA equal to PB. Those are lengths of tangents drawn from an external point P of the circle. Now, how can we prove PA equal to PB? Already these two triangles are congruent. Congruent means corresponding sides are equal and corresponding angles are also equal. That means these two are equal. This is equal to itself. Then what are the remaining sides? Pair of sides? Only these two. These two. Therefore, PA equal to PB. Therefore, PA equal to PB by CPCT. CPCT means corresponding parts of congruent triangles are equal. If two triangles are congruent, then we can say corresponding parts. Parts means sides and angles. Corresponding parts of congruent triangles are equal. The remaining sides, PA and PB, they must be equal. Therefore, PA equal to PB. PA equal to PB. That is the proof of the theorem. 9.2. Okay, no doubt. Again, I will explain again. First, draw a circle with center O. Locate a point, external point or outside point P. Draw two tangents to the circle. Then A and B are the point of contacts. Join OA and OB. Both are equal to radius. Join OP. Then two right angles formed. Two right angles formed. We are proving two triangles are congruent by RHS congruence rule. Then automatically corresponding parts of congruent triangles are equal. By using that property, we are writing PA equal to PB. That means length of tangents drawn from an external point must be equal. That is the theorem. Okay. Now we are going to discuss the construction of tangents to a circle from an external point. That means we have to perform constructions from an external point of the circle. This is the theory part. Already we have done, but it is a theory part. Now we have to go through practical. That means by construction. Okay, very, very important. Construction of tangents. To a circle from an external point. External or outside point or exterior point. All are same. All are same. Okay. We have to perform construction of tangents to a circle from an external point. Very, very important. Okay. For any construction, first step is, what is the first step? We have to draw a rough diagram. We have to draw a rough diagram. Right. For this also, I am drawing a rough diagram. First, draw a circle with center O. From an external point, locate a point outside the circle. Name it as P and roughly draw a, how many tangents possible from an external point? Already today we have learned only two tangents, pair of tangents are possible. point of contact A and B. Just join OA and OB. First, draw a circle with center O. Not now, not joining OA. Okay, no problem. Locate the point P outside the circle. Then we have to draw perpendicular bisector of OP. Perpendicular bisector. Not now. Don't join the PA and PB. Lastly, we can join. First, draw perpendicular bisector of OP by taking more than half the radius. Draw an arc above OP and below OP. In the same way, from P also, we have to draw arcs above and below, and by drawing a line through these two intersection points, this can be midpoint of OP. We are drawing perpendicular bisector of OP. Then the midpoint will be noted as M, taking M as center and radius as MO or MP. Draw another circle. This will be the first given circle C1. Now draw another circle with center M, taking radius as MO or MP, both are same since M is the midpoint. Draw another circle C2. Draw another circle C2, which intersects the previous circle C1 in two distinct points. In two distinct points. Observe here. These two are intersection points of two circles. Name them as A and B. Name them as A and B. Next, now join PA. P and A, the points next P and B. Right. PA and PB are the required tangents. Now we can join OA and OB for convenience. For convenience only. Join OA and OB. That's all. That is the construction, rough diagram of construction of pair of tangents from an external point to the given circle. This is the rough diagram. Okay. By following the rough diagram, we can construct fairly. For that, I am taking compass. I am drawing a circle with center O. Yes. I have drawn a circle with convenient radius with center O. With center O. Now we have to locate an external point to the circle. Locate here. Locate here. Some point to external point P. Now we have to draw pair of tangents or two tangents from P to the given circle. Call given as C1. Now join O and P, center and external point, with help of ruler. Okay. Join O and P with the help of a ruler. Now we are going to draw perpendicular bisector. We are going to draw perpendicular bisector of OP, of OP, line segment OP. Right. Now taking more than half of the distance OP. Why? Now we are taking more than half of the distance. Why we have to take more than half of the distance? If we take less than half of the distance, just see what happens. If we take less than half of the distance, draw arcs like here, above and below OP. From P also we have to draw arcs. From P also we have to draw two arcs, above and below OP. Then these two are intersecting? No. If we take less than half of the distance of OP, then the two arcs cannot be intersecting. Cannot be intersecting. That's why we have to take more than half of the distance. Then those are overlapping, are intersecting. Then those will be intersect. Now, taking more than half, draw an arc above OP and also below the line segment OP. With the same radius, from P, we have to draw arcs above AP and below AP. Above AP and below AP. Like this. With the same radius, we are drawing arcs from O and P, above OP and below OP. They are intersecting. They are intersecting somewhere. Here. Just locate these two intersection points and draw these two intersection points. Join these two intersection points with ruler. This is the perpendicular bisector. Now, say XY. Now, what about this point? This must be a midpoint of OP. Midpoint, first letter is M. In general, we call or we name it as M. The point M. Okay. M is the midpoint of OP. Definitely, M will be midpoint of OP. If we draw perpendicular bisector of OP. Next. Now, last step. With center M, by seeing rough diagram, first join O and P, draw a perpendicular bisector and name the midpoint as M. Now, taking with center M, okay, with center M, taking radius as MO, MO or MP. Let's see here. MO or MP. Draw a circle. Draw a circle. Is center M and taking MO or MP as radius. Okay. We are drawing another circle, which the given circle in two distinct points. Two distinct points. Now, the second circle can be named as C2. Now, locate these two intersection points as A and B, as A and B. Finally, join PA and PB. Join P comma A and P comma B. That's all. PA and PB are the required tangents from the given external point P to the given circle with center O. That's all. This is the construction of pair of tangents from an external point to the given circle. Join OA for convenience. Join OA and OB. OA and OB. Now, therefore, PA and PB are the tangents. Therefore, PA and PB are the required pair of tangents. Pair of tangents from external point P to the given circle. The given circle. That's all. Okay. Now we are going to prove a fact. C1 is the first given circle, and C2 comes in the way in procedure. In procedure, we are getting another circle C2. Intersection points as A and B. PA and PB are the required tangents. Now, observe C2. Observe the second circle C2. OP is the diameter of the second circle. Okay? OP will be the diameter of the second circle. Now, what about OAP? Triangle OAP? Triangle OAP is a triangle in first half, in semicircle. In semicircle, just observe. OAP, triangle OAP is a triangle in semicircle of C2, semicircle of second circle.
Hello. Pratap Reddy sir. Sir. Pratap Reddy sir. సార్ గురుమూర్తి సార్ క్లాస్ అయిపోయిందా? సార్ నెట్ ఏమన్నా ప్రాబ్లం వచ్చిందా ప్రతాప్ రెడ్డి సార్ దగ్గర? సార్ సార్ దగ్గర ఏమైనా నెట్ ప్రాబ్లం ఉందా? ప్రతాప్ రెడ్డి సార్. హలో సార్, ఏమన్నా నెట్ ఏమన్నా ప్రాబ్లం ఉందా సార్ దగ్గర? గురుమూర్తి సార్. సార్ గురుమూర్తి సార్, సార్ దగ్గర నెట్ ఏమన్నా ప్రాబ్లం ఉందా? సార్ లెఫ్ట్ అయినట్టున్నారు. సార్ గురుమూర్తి సార్. So that is the end of the today's class. This is that is the end of the today's class. Already construction of tangents, which is from a given point which is outside the circle, which is explained by our Pratap Reddy sir. And tomorrow we will discuss about the questions in exercise 9.2. So this is Mova Prasad signing out from DCB Suryapeta, Khammam. YouTube channel DCB Suryapeta. గురుమూర్తి సార్ లైవ్ ఆపలేదు.
Prasad sir, over. Okay. హలో
సార్ ప్రతాప్ రెడ్డి సార్.
సార్
అయిపోయింది సార్. గురుమూర్తి సార్ లైన్ లో లేరు.
ఓకే సార్, అయిపోయింది సార్. రేపు కంటిన్యూ చేస్తాను.
ఓకే ఓకే సార్.
ఓకే, థ్యాంక్ యూ.